All right, this is exam 2 for Physics 202. First, want to find which of these equations is correct. So I just sort of begin with each one. So let's start with A. I'm starting at the 4-volt battery going in this direction because it's positive. And then that's minus 2I1. That's correct. 2 times I1 is negative because I'm going with the current. Minus 12, that brings me here. That's correct because I'm going from high to low potential. And then minus 3I3. Okay, that should be positive 3I3, so that one's not correct. Here I have minus 4. Rid of this. Minus 4, that means I'm going in this direction. Minus I2, right, that's correct so far. Plus 5, plus 2I1. 2I1 is positive because it's going against the current, so B is the right answer. Let's just do these others as well. I1 plus I3 is equal to I2. Let's do the junction rule up here. I1 is going out, I2 is going out, oh, and I3 is going out as well, so it should be I1 plus I2 plus I3 equals 0. So C is not right. And then minus I1, so minus I1, well, that would imply that there's a 1 ohm resistor that has I1 going through it, so that one's not correct either. So B is the right answer. Which of these statements is true? Household circuit is a parallel circuit. They operate at the same voltage. As you add more devices, the total current increases. That's correct. GFCI turns off if IN is bigger than I out. So it's 3 and 4. That's A. Wires in this junction of currents is labeled was the unknown current. All right, the 7 and the 3 come together to give you 10 amps, and then the 10 and the 2 come together to give you 12 amps. So the answer is A. The switch is closed. What happens to the potential across R1? All right, if this switch is closed, then the resistance of this whole thing goes down. If that resistance goes down, then the voltage of that whole set of parallel resistors also goes down, and that means that this voltage has to go up. So for number 4 is A. Two resistors are connected in series with an 18-volt battery. One of the resistors has a potential of 6. What is the potential across the other? All right, 6 plus the voltage across the other battery has to equal 18. That's when they're in series with an 18-volt battery, like that. So if I have 18, 6, that means I have to have 12 volts here. So the answer is A. What purpose does third prong serve? It's a ground. Safety feature, it's a ground. In a single circuit within your house, what happens to the total resistance as you add electrical appliances? The total resistance decreases. How are natural magnets created? Molten metal solidifies in the presence of a magnetic field. Which of these statements is true? All permanents are ferromagnetic. That's true. Not all ferromagnetic materials are permanent magnets, but the opposite of that is true, that all permanent magnets are ferromagnetic, or rather the converse, I guess. Opposite poles of a magnet attract. That's true. Magnetic monopoles do not exist. That's true. So the answer is D. The Earth's magnetic field plays a role in the aurora borealis. That's C. It doesn't play a role in any of these other things. Negatively charged particle in a magnetic field is shown. What is the force acting on the particle? All right, use your right-hand rule. Fingers in the direction of V to the right, they fold into the page, and so that gives us a force that's up. However, it is a negatively charged particle, so the forces opposite that are down. So answer to number 11 is C. Number 12. This wire feels a force to the right, so my force is to the right. What is the direction of the current? All right, so my force is to the right. That means my thumb goes in the direction of the force to the right, and my fingers have to go into the page. So that means that my current is flowing down. So number 12 is B. Coil of copper wire is allowed to rotate about the axis shown on the dashed line, has a current going through it. What is the initial direction of the rotation for the coil? All right, you can just pick one of the sides of the coil. I'll pick this one. Have a current coming out of the page. The magnetic field is to the right, so it feels a force that's up. Likewise, over here, with a current that's going into the page, we'll feel a force that's down, and so that causes for a clockwise rotation of that loop. That's B for 13. This figure shows the path of a charged particle. What is the charge of the particle? I have a force that's up. That's what's causing it to take this path. So I use my right-hand rule. Magnetic field is out of the page, and if this was a positive particle, then by the right-hand rule, it would feel a force that would be down. That's for a plus Q. But it's a negative particle, so it feels a force that's upward. So that's B. See, that's the end for the multiple choice. I just counted it as if there were 15, even though there were only 14 questions. So you got a free question in there. All right, let's do this one. You first want to pick your currents and label their directions. So you just pick these randomly. I chose them to be like this. This is I1, I2. I chose here, and then I3. I chose right there. So choose your currents, pick their directions, and then you write 3 equations. You want to write the junction rule, or let's see what I did. Let's write my junction rule first. I'll do it up here. I1 plus I3 are the incoming currents, and the outgoing current is I2. And then do the, let's see, what did I do? I3 minus 2. I did the right loop next, and that's going to be, I did the right loop starting right here and going in this direction. So that is positive I3 times 1, that's my resistance, minus 2, that's coming along up through here. I go across this resistor, big to little, so it's negative, plus 2I2 equals 0. Alright, so that's my right loop, and then I did 4 plus 2I1. I did the left loop next, so this is my right, and then I did my left. I did 4 plus 2I1, starting here, going in this direction, plus 2I1, minus 2 plus 2I2. And then that's equal to 0. So now I want to solve those, I'll call this equation 2 and equation 3. I'll call this equation 1. I'm going to solve equations 2 and 3 for I3 and I1. So I can do that right here. I get I3 equals 2 minus 2I2. And then here, I'll solve this for I1. And I get I1 is equal to 2 minus 2I2 minus 4 divided by 2. So that's 1 minus I2 minus 2. Just make sure I did that correctly. So I'm solving for I1. I get 2 minus 4. Yeah, so that is equal to 1 minus 2 is negative 1 minus I2. Now I want to plug those into equation 1 and solve for I2. So I have negative 1 minus I2 plus I3, which is 2 minus 2I2, equals I2. And then I solve that for I2. I get negative 1 plus 2 is 1 equals 4I2. And then I2 is equal to 1/4 amp. 1/4 amp. So that's, I'm going to write this up here, 1/4 amp, and it's down. So I'll ask for the direction as well. If it comes out positive, then it's the same direction as you chose for the current. All right, you can plug in for I3 and I1 right here. To get I1, it's -1 minus I2, -1 minus a quarter. Um, that's -5/4. And so the answer is 5/4 of an amp. It's negative for I1, so it should be, I labeled it up, it should be down. Or I would also take, see, I labeled it clockwise, counterclockwise, either down or counterclockwise. And then for I3, you do a similar thing and you get 7/4 of an amp. That's 2. Let's see, I'll just do it right here. 2 minus 2 times 1/4, which is not 2 1/4, but 2 times a quarter, which is 2 minus a half. Let me make sure I'm doing this correctly. I3 is 2 minus 2I2. Yeah, so that is 2 minus 1/2. Should be 3/2 of an amp. Yeah, 3/2 of an amp. And it's positive, so it should be up or counterclockwise. Same as what you've labeled. All right, if you did the matrix method, I gave you extra credit on that. All right, let's see. Want to find the equivalent resistance here first. These 6 and 3, 1 over 1 over 6 plus 1 over 3 is equal to 2 amps. That's 2, that's a 4, and so my equivalent is 6 ohms. This is ohms. And I have 12 volts, and then I can find the current here. I is equal to V over R. That's 12 over 6, which is equal to 2 amps. That means that I have 2 amps coming here. All right, so that's also the current that goes through R1, 2 amps. I can find V1 is just going to be I times R. That's 2 times 4, which is equal to 8 volts. And then I'm going to do P1, which is VI, which is 2 times 8 or 16 watts. All right, now that I know that there are 8 volts here, that means that there are 8 volts on this resistor. Since I have 12 volts total, that means that I have to have 4 volts here. And since R2 and R3 are in parallel, they have the same voltage, so they're both 4 volts. Then I can also find the current as just V over R. That's 4 over 6, which is 2/3 amps. And then for V3, should just be 4 over 3 amps, 4/3 amps. That's V over R. And then I can find my power, which is V times I, which is 8/3 watts and 16/3 watts. The circuit shows 2.8 meter length of wire. All right, your first thing that you want to do here is define what L is. L is going to equal to the X component of this wire times the Y component of that wire, or plus the Y component of that wire. That's going to be L cosine of 45 in the I direction plus L sine of 45 in the J direction. All right, notice that the X component, which is here, and the Y component are both positive, and so that's why I had them both positive. The length of the wire is 2.8 meters, so 2.8 times the cosine of 45 is 2I, and 2.8 times the sine of 45 is also 2, so it's 2J. I tried to give you easy numbers. All right, so that's my L vector. I also need to find the current. I have a 12-volt battery and a 4 ohm resistor. So that gives me 3 amps of current. And then to find the force is just IL cross B. Do the cross product, so that's 3 amps, 2I plus 2J, crossed with the magnetic field. Magnetic field given is 3T in the negative K direction, so negative 3K, 3 Tesla in the negative K direction. All right, so I do 3 And then I get negative 6 I cross k plus negative 6j cross k. You can use your right-hand rule to find out what are I cross k and j cross k. And our final answer is going to be 3 times 6j minus 6i. I cross k, that is negative j. J cross k is positive I. So this is equal to 18j minus 18i. And this is in newtons. Proton moves freely in a circular path. And this is a homework question, basically. It was a homework question. I think it was verbatim. QVB is mv squared over r. This is my magnetic force, but it acts as a centripetal force, so I set it equal to mass times the centripetal acceleration. And I want to know the magnitude of the magnetic field, so I solve for B, mv squared over rq v. One of my v's cancel, but I don't know what v is right off. But I do know that v is equal to the distance over the time that it travels, but it's a circular path, so the distance is the circumference over the time, and that time is just the period. The period is given, so I can plug that in. M 2 pi r over t r q. The r's cancel, that's good because you don't know them. Now I can put in my values. Let's see, 1.67. That's the mass of a proton. 2 pi divided by 1.6. That's the charge of a proton, and the time given was 1.2 microseconds, so times 10 to the minus 6 seconds. And that gives me 0.055 Tesla. So that's the answer for number 18.